Go ahead.
I hear both. Can you? Yeah, I do. Can you repeat the question? Like when you're reporting to a watching at home? I can never understand.
I'll try to remember. I will try my best. I'm not going to promise right now, but I will try. So Elizabeth wants to know if I can repeat the question, and my answer is I will try. Okay. Thanks. Better than my frog? Is that what you're saying?
Mr. Baban, draw that.
Ooh, that's horrible. That's the idea. There. Okay. So there's Anne, and Anne's going on her trip. Now, Anne's on the wheel, and when she is here, she has rotated a certain angle. Okay? Let's actually say that she's rotated 30 degrees. Is that okay? Can we say right now theta is equal to 30 degrees? Based on knowing that she's rotated 30 degrees, we can actually figure out how high she is. The thing that we need to know is we need to know the radius of the wheel. And we said in this case, to keep it simple, we'd have the radius would be 1. Is that okay? We can change that anytime you want. But for now, let's just say the radius is 1. If you want to find out how high she is above the water or how far off, yeah, we have a triangle. And if I know that the angle is 30, I'm going to call this, guess what I'm going to call this? I'll call this y, and I'll call this x. Does it make sense that y would be how high and x would be how far over? Okay. Okay, so Raphael is starting to, she said, do we need SOHCAHTOA? She's starting to see that this is how we're going to bring trigonometry into this whole thing. So if you wanted to find out how high she was, you would set up a ratio. And what ratio uses y and the radius? Which one is it? Sine of an angle is the opposite over the hypotenuse. Right? So in this case, the sine of the angle would be equal to y over r, which is going to be 1 in a second. But this is a very important relationship. In any circle or Ferris wheel, the sine of the angle is equal to y over r. So now let's do it for this specific example. For this specific example, the sine of 30 degrees is equal to y over r, but since r is 1, y is equal to the sine of 30 degrees. And we should probably go and check out our calculator. Make sure that you are in degree mode. Your calculator has 2 modes. And if you click on mode, you arrow down, and by default it's in radians, and you're wondering what radians is, and in a week I'll let you know. Now, my science friends, specifically my physics friends, Mo and Tom, you are now at a very crucial juncture in your math science career where you actually have to remember to be in the right mode. Okay? So if you are in degree mode, that's fine for physics, but next week you might have to be in radians for pre-calc. All right? So make sure you're in degree mode. Second, quit. The sine of 30 degrees is 0.5. So this actually tells us after she's rotated 30 degrees, she is 0.5 above the water. Evan.
So when you do SOHCAHTOA or like sine, cosine, or tangent, are you always doing like sine of a degree or cosine of a degree?
Yep.
Will we ever have to find the degree?
Yep.
How do you know which to?
Definitely.
But it's always a degree in front of something.
So you're always taking the sine of an angle, okay? And the output is the ratio. And sometimes you can use the inverse sign if you know the ratio and you want to find the angle. And that's the sign with the -1 above it, okay? So we did this, I think, in geometry. Like, sometimes you want to find the angle, sometimes you want to find the ratio. Here, we wanted to find the ratio, and the ratio is 0.5. So that tells us the y value is 0.5. I could ask the same question about how high is she when she's traveled 140 degrees. Okay. Do you agree that at 140 degrees now she's in the second quadrant? Okay. So guess what? All you need to do is do sine of 140. And she's 0.64 above.
But is this 140 on top of the 30 or is it
No, sine of 140 degrees. The 140 is how many degrees she's turned, and the 0.64 is how high above she is. So now, how high above the water she is. So when she's turned 140 degrees, the y value is 0.62. Guess what happens if she turns more than 180 degrees? She's going to go under the water. So if you go, and let's just pick a number like 200, because that's greater than 180, right? If you do the sine of 200 degrees, it's no surprise, it's negative. She's under the water. Is that okay? What would happen if instead of r was 1, if I made r like 5? Okay, so if you spin 30 degrees now, is she going to be higher than 0.5 or lower than 0.5? Higher. And exactly what Danny said, I know that the sine of 30 degrees is y over r, so Danny just said, look, that means y is equal to r times sine of the angle. So if the Ferris wheel, or the wheel, is 5 feet, just take the sine and multiply by whatever the radius is. The bigger the radius, the higher she's going to be. 2.5, exactly. Is that okay? It's hard. It's a lot. Do you want to ask a couple questions? So let me show you. If I actually went back and graphed the sine of x, and if I go to my window and set it from 0 to 360 degrees, and I'm going to set my x scale to be 90. Every 90 degrees it will mark. And I'm going to have my y go back and forth between -5 and 5. Let's look at this graph. That's a graph of what Anne's height is. It says that she starts off at the water, and over time she goes above the water, she goes back to the riverbank, then she goes under the water, and then she goes back and repeats the whole thing. Do you see how the sine of the angle actually describes how high above or below she is? Is that okay? Evan?
So when we're doing sine or cosine tangent, and it's like opposite, it's like opposite or hypotenuse or adjacent, are you always taking like the opposite from the perspective of an angle?
Yep. Always. If this is the angle, you put your finger on the angle right here, and the opposite is if you walk across, where would you be? That's the opposite. Okay? Yep. That's all right. I couldn't have asked for a better comment, Monty. And I said this in your comment too. I said you always say the right thing at the right time. So yeah, I know. I did say it a couple weeks ago. So if instead of measuring how high above or below Anne is, if I want to measure how far away, I think Elizabeth said, from the y-axis, that would be the x-coordinate, and that would be the cosine is equal to x over r. So that's the other really important relationship, which is adjacent over hypotenuse. So we can measure both how high above or below Anne goes from the water, and then to the left and to the right. And the important thing is the relationship, is that the y-coordinate, or the height of an, is r times the sine of the angle, and the x-coordinate, or the distance from the y-axis, is r times the cosine of the angle. And those relationships can help us, answer questions or figure things out based on the information they give us. Sometimes it'll be like a math question. Sometimes it'll be like a Ferris wheel or a context question. So this whole idea that sine measures how high above or below and cosine measures how far to the left or right is a very new concept. We've never done that before. We've only talked about sine and cosine as being like opposite over hypotenuse. But now all of a sudden we're saying, hey, not only that, sine tells us how high above or below the circle goes. Like if you're on a Ferris wheel or something. You're not as impressed as I am. I know that that's hard, and I think that's why I'm making a big deal about it. So if I were to take a look at like this problem from the classwork, from 13 from the classwork, it asks me to find the coordinates of the point. And all I know is that I've traveled 140 degrees on a circle that has a radius of 1. Well, guess what? I know what the x-coordinate is, and I know the relationship to the y-coordinate. What's the x-coordinate equal to? R, which is the radius, times the cosine of whatever the angle is. Okay? So in this case, Travis had the radius, which is 1, and we have the cosine of 140 degrees. So the cosine will tell me how far away from the y-axis I am. So go ahead, plug that in and tell me what we get. Anyone? Negative what? Negative 0.76. Are you okay with the fact that it's negative? Yeah, definitely. Doesn't it make sense that we're to the left of the y-axis? And without even doing it, we will, but what's your expectation for y? Positive or negative? Is the y above or below? It's above. We're hoping it will be positive. So for the y-coordinate, we're just going to type in 1 times the sine of 140 degrees. What do we get? 0.642. Is that okay? Question, comment, consideration.
Sorry.
No. We're going to have a lot of these. This is good.
So sine always goes with the x-axis, and
So if I had to leave you thinking about one thing today, it would be think about sine as measuring the y value, or how high above or below the x-axis, and think about cosine as measuring the x value, or how far to the left or right you are. Okay?
So what about tangent?
Not ready for that.
Okay.
All right, just sine and cosine for now. I think that's a lot for now, actually. And we'll talk about the tangent function and some other functions, I think, later next week. All right, so here's the deal, and I mean this sort of seriously, sort of joking. The homework might make you cry a little bit, and that's okay. I'm fine with that. You can certainly bring in tissues as proof that you were crying all weekend doing the homework. I would try to do it sometime today, because if you wait until Monday, it's going to be really hard. And we're going to do it again on Monday. So I want to reassure you that if it doesn't go perfectly the first time, we're going to have a second time with it. It's hard, and I get it. All right? All right, it is high five.
We have a pop quiz on Monday?
A pop quiz for you, Ed.
First high five currently is
I love that.
Yeah.
Yeah, I love that.
You have a number, don't you? Stars. Stars.
All right, I like that. All right, have a good weekend. Have a wonderful weekend. Have a fantastic Friday. Have a good weekend. Nice nail polish. Holy cow. Have a good weekend. Fantastic Friday. Have a great weekend. Have a fantastic Friday. Oh my gosh, you got a lot of books there, kid. And a full book bag.